Hello and welcome to this episode of Spacetime Fika, where I will discuss the craft of science writing with Marsha Bartuszek. She is an acclaimed science writer who has published several prize-winning popular science books about astronomy, including Dispatches from Planet 3, The Day We Found the Universe, and Einstein's Unfinished Symphony. Marsha is a fellow of the American Association for the Advancement of Science and has taught science journalism and writing as a professor at the graduate program in science writing at the Massachusetts Institute of Technology. I met Marsha to learn more about how to become a better science writer, and we discussed topics such as how to develop a relationship with scientists, how to handle the feelings and techniques involved in the writing process, and how to find good science stories. This episode contains great pieces of advice from Marsha that I think will be useful for anyone who is involved in science writing. I hope you enjoy this episode. Okay, Marsha Bartuszek. Welcome to this episode.
It's a delight to be here.
I'm super happy to have you here because you're one of my favorite science writers. You're an extremely experienced science writer, and I just look forward so much to talking with you today and learning about the craft.
I've been looking forward to this too.
Yeah, great. And let's just start off a little bit with what are you up to these days? What are you doing?
Well, I'm now retired, so I am putting away my past writing about the frontiers of astrophysics, and I have been doing more work on the history of astronomy. I've had more than 40 years covering the fields of astrophysics and astronomy, and so I feel I can now look back and add my own thoughts of how the history of cosmology and astronomy have developed over the years that I've been covering it, and even before that. So I've been enjoying doing that and book reviews for various newspapers, the Wall Street Journal, Washington Post. I have fun doing that too. So I'm quieting down and sitting back on my laurels.
It sounds great. And we're going to talk about specifically the craft of science writing and, your trajectory as a science writer, how that has been developing with time. So I thought we would just start with the question how you started with science writing in the first place.
It was a long and winding road because when I was in college, I was interested in so many things. I was interested in science. I was interested in English literature, the arts, humanities. I loved writing. And I thought I can put this all together by majoring in journalism. So my undergraduate degree is in journalism. And my first job was as a television reporter in Norfolk, Virginia, covering city politics, doing general features. But my favorite thing to do was going over to the nearby NASA Langley Research Center and covering what they were doing. At that time, especially, they were developing the Viking lander that would, in 1976, land on Mars. And I loved doing those stories. And after 4 years of as a general reporter, I decided it would be heaven if I could do science reporting 24/7. So I started taking courses at night, boosting up my science background. And I did so well in my courses, one of my professors suggested that I come into their graduate program. And so I quit my job and I got a fellowship and got a master's degree in physics. And it was at that point that I finally put the two together, my writing skills and my physics degree, and started writing about physics and astronomy. First for Discover magazine. I was on the charter writing staff when they first started up in 1980. And then I went freelance, working for a number of contributing to a number of science magazines. It was the golden age of science writing in the 1980s, 1990s. So many science magazines out there that are no longer. Science Digest, Omni, Science 80, whatever. They always change their name each year, Science 84, 85, 86. And I wrote for all of them as a freelance writer, and then started getting into books and doing books. So it went from there. And
before we started this recording, you mentioned a little bit about some of the things you covered in the 80s, like dark matter, some of the first quantum entanglement experiments. You were really spot on early on.
And I was totally surprised. I remember being at a conference in the 1980s where I was just starting out. No one knew me. And there at the conference was Walter Sullivan, who was the premier New York Times science reporter. He covered all the great stories of that era, the rise of X-ray astronomy, the development of X-ray astronomy, radio astronomy. The plate tectonics was coming out, and he covered that all at the New York Times. And I remember looking at him, interacting with the scientists so informally, and they all knew him. And I said, oh, I missed my chance. I'm just going to be the cleanup operation. He got to be there when all this new instrumentation, new arenas into the other areas of the electronic spectrum, electromagnetic spectrum. I missed that. I'm just going to be covering the follow-ups. And boy, was I wrong, because I soon was doing some of the first stories on dark matter. I did a story on a potential meteorite from Mars. This was in the 1980s when it was highly controversial, and now everyone, yes, agrees that occasionally we will get a meteorite plummeting to Earth that had gotten off of Mars. And the large-scale structure of the universe. I was in on the very ground floor of that, and also covering the very, very beginning of trying to build the equipment to capture gravitational waves, vibrations in space-time. So by the 1990s, I was realizing there's a lot going on, and I'm right in the thick of it, and it was just a pleasure.
It sounds very good to hear. And for example, Gravitational Waves, that's one of your books, Einstein's Unfinished Symphony.
That was one of my... I look back at my career, and I think I am most proud of the fact that I was able to see that start from the ground floor. My first story was in Discover magazine in 1985. And my story actually was focused on the big super cold bar detectors that they were building, one at Stanford University, that they were hoping as a gravity wave passed through the bar, it would vibrate and they'd capture the gravity wave. And along the way, in doing my research for this story, I heard there was this small group at Caltech and MIT that were looking into a whole different technique using lasers, where they would bounce lasers between mirrors that would keep measuring the space between the mirrors and see if the mirrors moved ever so slightly as a gravitational wave went through. And so I went to Caltech, and Ray Weiss happened to be visiting at that time, visiting Kip Thorne, who was the world's top theorist on the theory of gravitational waves. And I sat down, and that was actually in the second half of the story. Oh, by the way, there's this idea, and I remember seeing a picture of their imagined gravitational wave observatory, and at that time they imagined it in the Mojave Desert. And I looked up at the billboard, the bulletin board, and I said, well, I'm never going to see that built in my lifetime. And boy, was I wrong. But because of that initial story, I kept in touch, and I kept following them and I kept doing a story about every 5 years until the point that in the late 1990s, when they were actually starting construction of what came to be called LIGO, what is known as the Laser Interferometer Gravitational Wave Observatory, one in Louisiana, one in the state of Washington. And I turned that into a book about the whole history of how the search for gravitational waves, starting with Einstein's first imaginings in the 1910s, and then the work of Joseph Weber starting up to actually build an instrument in the 1950s and 60s, and then leading into the foundation of LIGO. Of course, that book was published in 2000, and I had some complaints from critics going, she wrote this book too early. They haven't detected anything. And it was another 15 years. But the scientists knew that. They knew that it was going to take a long time for them to construct these huge observatories and use them as test beds to test the equipment, upgrade, and they knew it was going to take time. And fortunately, the United States government backed them in keeping the money flowing. They could have turned it off like the super collider that was supposed to be built in Texas. Fortunately, they didn't. It took 15 years, and now they have opened up an entirely new field of astronomy, something that I never thought would happen. Back when I thought Walter Sullivan had captured it all, no, I was able to be at the ground floor and over 30 years see the founding of a field and see how it is now changing. And it's turning out to be a terrific tool that is going to do so much for astronomy. It's the first time they're getting masses of black holes to even prove that a black hole exists. This was the detection was the first direct proof. And when they finally detect the gravitational waves from the Big Bang itself, that is the only way that we can actually go back to the very moment of creation, because electromagnetic waves are blocked from all the plasma. But gravity waves go right through matter as if it isn't there, and they're going to be able to actually see the moment of our birth. That is just so exciting.
Yeah, LIGO is one of my favorite experiments, and the best part of it is that they are just getting started. It's such a new thing.
When I started 30 years ago, there was maybe a dozen people working on it. When I was at Caltech, I talked to about 6 people, and that was the team. That was it. And when they had the detection, it was over 1,000 collaborators all over the world. And that's how the field grew so quickly. And now it's the in-field for everyone to go into. And they're coordinating now with the telescopes to coordinate the sightings of the terrific violent events in the universe and coordinating seeing the gravitational waves along with the radio waves and optical waves and X-rays.
Right. So let's talk about that part of the LIGO experiment and your book writing about this. So what I'm curious to know is what you're describing here is a very complex history. It's over 100 years of scientific research. There's today thousands of people working with this. It's a very complicated instrument. And then there's also individual biographies. You mentioned Rainer Weiss and Kip Thorne, who got the Nobel Prizes, for example. So when you were writing about this, how do you actually choose a story, like what to focus on? Because there's so many elements, historical, instrumental, science facts, biographies. There's so much material. How do you put it all together?
I do a lot along the way. I look upon it as a crystallization. Some writers will do research, and then worry about the writing afterward. I'm writing along the way. First, the very first thing I do is an intense literature search. And once I have the literature search, then I'm on the phone and I'm talking to a lot of people. And I am transcribing these interviews. And I immediately then start picking out quotable quotes. I start seeing threads connecting people together. I'm starting to see the science, and I'm starting then to try to interpret the science, bringing in metaphors, working with the scientists. Does this metaphor work? Am I too far off the beam here? Or is this going to help a layperson understand the process? So I am doing a lot of note-taking along the way. And I usually have, I think of them as bins. I have a sort of rough outline, like with a book, and I know how the story's going to go. Basically, it was chronological, but it was separated into sections. And when I have notes, I start putting them in the bins. Oh, this is a great story for chapter 1. This is a great story for chapter 6. So along the way, I am already starting to filter, so that when it comes to the actual writing, I will then handle it chapter by chapter, dealing only with that material that I stuck in the bin. And that helped me not feel overwhelmed. Because my very first book, I didn't do this. And I absolutely had writer's block for about a month, where I just couldn't see where I was going to go and how I was going to work it out. And I realized that the essence was just write anything down. I was trying to make it perfect from the start. And I realized you can just write your thoughts down. And oftentimes those initial thoughts are what end up on the page. I remember one time I was doing a story on the Very Large Array in New Mexico, where they have this network of telescopes that coordinate and work as one. And I was driving to it, and I came over a hill, and there it was in front of me. All of the telescopes, my very first view of it. And I was like overwhelmed, and I stopped the car, and I wrote down my very first impressions. And those very first impressions, as I wrote them, ended up as the lead of my story. So that's really what I'm constantly doing as I'm out and about. If I see something, I write it down. If I have a thought after an interview, I write it down. And then I dump them into my computer, starting to filter them into a rough outline so that it makes it handleable.
So in this case, it seems to have been done for the book about gravitational waves and LIGO, a key decision to make a chronological ordering to get those bins there. Have you used other structures instead of the chronological structure for other books?
Actually, now that I think back on it, there was my book Through a Universe Darkly, where I did have a division between, it really was a history of the universe through learning what's in it. How did we learn the matter in the universe? And I divided it into light and dark, because there was this dramatic division when we learned that the matter that we see and glows and lights up the universe when we see the galaxies is just a minor part of the major part of the universe. The other is dark matter, of which we still don't know what that is. But that book was then arranged more in light of how did we discover the initial contents of the universe, and then step back and how that changed, and how did we learn that there was something else. So that wasn't quite chronological. So
okay, so more of a thematic
yes,
ordering.
Yes, yeah.
Okay. And how, so I'm so curious about your writing process. So I'm just going to ask questions about it. So how much, when you wrote these books and articles, how much do you write per day? Like how?
Oh, gosh. I always think back on Isaac Asimov, who always declared that he was going to write 2,000 words or 1,500 words a day, and that was it, you know, and he did it. And that was with a typewriter, too. I usually have a general sense of I want to reach the end, have a draft of a chapter at the end of a specified time. The one thing about book publishing these days is, as I've noticed, I've written 7 books, and I've had shorter and shorter time frames to write them because the publishers now want you to bring the book in faster than when I wrote my first book in 1986. So that I feel more, I feel that clock ticking. So from the very start, I always keep in mind that I should have a certain number of chapters written by a certain, and I do take it chapter by chapter once I've finished that filtering process of all my research notes. And so that's really my gauge. Some chapters come easily, where, oh my God, it's all falling into place and I have a draft within a few days. And other chapters, I'm struggling and it takes a little longer. But I try to keep it going, keep moving forward. Don't try to enter that zone where I want it perfect from the start, which I always told my students, you can't get it perfect from the start. Revision is part of the process. In fact, that's where the fun is. I always find if I have something in print in front of me, no matter how crude or raw, it's fun to then print it out, pencil in hand, and I actually do a lot of editing that way with a pencil in hand rather than go back to the computer, because I find that the thoughts just flow through my hand into the pencil onto the page, but it's working with stuff that's already there. And so that's easier for me too. So it's a constant, just keep moving forward, but know you have those deadlines and try to meet them.
Right. So deadlines can be a source of inspiration because you have to.
One of the reasons I'm enjoying my retirement is I tell my students, I said, no more deadlines, and if I'm doing a book project, I will write the book first. And then my last 2 books, I wrote the book and then submitted it to the publisher because then I didn't have to worry about the deadlines.
Right. And you mentioned the editing as a fun process. So that's also a key component, I guess, as a writer, is to know your feelings a little bit, because it is a very emotional process to write. How are those feelings kind of distributed for you in terms of frustration, fun, agony, inspiration?
I like Dorothy Parker. She was hung out at the Algonquin table, but I always like to quote Dorothy Parker. I loved having written. You are tearing out your hair when the metaphor's not coming. You can't see how to write that transition from one paragraph to the next. But when you figure it out, you sit back, and you feel so good about it when it works. It's a high. It's an absolute high.
When you have text that is finished or almost finished, do you read it out aloud to kind of test it, how it sounds?
That is my broadcast experience coming into play. Yes, I always read aloud, because if you stumble over it while reading, then that's a clue that the reader might also be stumbling over that sentence formation or that long phrase. So yes, I do that. I also show it around. My husband is a great editor. He helps me a lot, telling me, ooh, I think you need to explain this a little better. And we'll play around. He also has a scientific background. He's a mathematician. And so we'll sometimes play with ideas and metaphors that might work. But then you're also working with your editor, who is seeing the work and giving you feedback. In fact, we were talking about books being in chronological order. My initial draft of the book I wrote about the the origin of the field of modern cosmology, Edwin Hubble and his work in discovering the modern universe, I initially broke the book up into two sections. One, the work on discovering that there were other galaxies, and then a second part where I talked about general relativity and how it led to the discovery of the expanding universe. And my editor came back and he says, no, keep it chronological. So there I had to take a book where I had separated it out and had to refashion it so that the story could be told through the years on how it happened. He thought that since it was a history, that we should maintain how the community thought about it at the time, in the time frame that it occurred. And it worked out beautifully. And actually, I'm glad he made that suggestion because I think it made it better.
So when he made this suggestion, did you immediately accept it, or was it a discussion? Or
I recognized the value of it. Something I've learned over the years. Listen to your editor. When I was first starting out, I did have a little chip on my shoulder saying, that editor doesn't know the material the way I do. This is the best way to do it. And now I look back on some of the first stories I did, like for Discover magazine, and I read them now and I see how I changed it according to the editor's instruction, and I was all in a huff about it. And now I look at it and I go, yes, they were right to suggest that it's much better the way it is. Where at the time I was so caught up, and I've told my students this. I said, you have to listen to the editor. Yes, sometimes you get an editor that you just can't work with, and you just throw up your hands and you do it, and you never want to work with them again. But most of the time, they're there for a reason. They are viewing the material, one, because they are representing the magazine. They know the magazine. They know their readers. They know what's going to work and what isn't. So you have to listen to that. And I learned that lesson, and it's been very valuable ever since.
So that's something to take away for aspiring writers listening to this.
Yeah. Don't be so quick to say, I know how to do it better than you do. You work with the editor. That's not to say that you can't forward an argument on why you need to do it the way you did it. Sometimes they'll be convinced. Oh, I avoided that way because, and you give your explanation, and then they say, oh, now I see what you're trying to do. Maybe if you just add in here a little something, and then everyone's happy. So you work with the editor. You don't work against them.
Right. And I guess there's also a risk that if you go very deeply into a material, you become a little bit blind for, you have too much knowledge about it.
Oh, definitely. Yeah. And that's something that you want to avoid also. You're so familiar with the material that you forget. Someone reading it new doesn't know all the nuances. And sometimes you're writing in such a way that you know what you're writing about because you know all those nuances that aren't on the page. But someone reading it new doesn't know that. And so a sentence that makes complete sense to you may be meaningless to a new reader. So that's, again, where an editor is very, very valuable. They're showing you those potholes that you need to fill.
Right. So you mentioned metaphors before, and also that you were discussing metaphors with the scientists, and I guess also with the editor and so on. So I'm going to read a metaphor. No, it's not a metaphor, it's a simile. Simile. Okay, thank you. This is from Dispatches from Planet 3, and you, in this one of the articles in this book, you describe when they were measuring the first spectrum of quasars. So these distant objects where people didn't know, are they in the galaxy or the other objects further away? And they got the electromagnetic spectrum of these quasars, which looked really weird and different. And you write about one of the astronomers when he saw this spectrum for the first time. You write that, quote, "It was like riding down a familiar turnpike and finding all the road signs written in gibberish." I think that's a really nice simile for this. Could you describe, like, what did you think when you choose that, and how much do you work with similes and metaphors and so on?
Well, it's the bread and butter of our field. I always told my students, you are not here to teach science, because then it would just turn into a textbook. And that's not really, especially to a general audience that doesn't have the background. They're interested in the topic. They're interested in quantum mechanics. They're interested in the expanding universe and the Big Bang. They don't have the mathematical skills or the scientific skills to understand it on the real technical level. So what you want to do is find a way. I like to quote the New York Times reporter George Johnson, take the strange and make it familiar. You want to find the metaphors so that the process going on is put into terms that are familiar to them from their everyday world. So I'm always looking for those examples that will make it they'll understand or have a gut understanding of how it works, how the particle wave duality works, or how space-time is stretching, or that it's a fabric of space-time. They get a picture. There's a great visualization, and you want it centered on things that are familiar to them in their everyday world. That's what you're looking for. Sometimes, you have to work with the scientists, because some are very happy to do that. They understand that the metaphor may not be the perfect fit, but it's the best fit to give somebody an idea of the discovery or the theoretical idea. But I do like to work with the scientists. I always, in all of my magazine articles and books, I always go back to the scientist and I say, does this work? And if not, how can we make it better? And so sometimes I've gotten some good ideas from scientists themselves. But sometimes it hits me in the moment.
Right. But that also sounds like a very great advice, to actually work with the scientists on the metaphors.
Well, I basically, I'm not doing investigative journalism, so I never worried about discussing my, especially with the books, where I am synthesizing a lot of material to tell people a story about a certain field, a certain idea. So I think of myself as an explanatory science writer, where I really do want to write for a general audience, for them to understand cosmology, black holes, gravitational waves. And so working with the scientists can be very helpful to find that middle ground where you get the science right, and they're not going to tear their hair out when they get a copy of the book and never want to talk to you again.
Yeah. But talking more about the question of how to portray the science, there is this very famous saying that you should show, don't tell. Is that always true in science writing? Because sometimes there's just a lot of facts and you just need to present the facts sometimes. Or what's your feeling about this? How to make it lively?
I always want to find a story. I always want to find a story. I remember sitting down with Ray Weiss when I was researching my first book, Einstein's Unfinished Symphony, on gravitational waves. And he was telling me how the gravitational waves, as detected by LIGO, happen to be in the same frequency range as sound waves. And so he says, when we record them, we'll be able to play them back as sounds so that you will hear the black holes colliding or the neutron stars colliding. And I found that fascinating. And I said, well, how do you feel about, here you're working on gravitational waves and you have to worry about acoustics? And then he started telling me this wonderful story about when he was in high school in New York City. He was fascinated with acoustics and went to like auctions and supply stores and bought up old speakers and electronic equipment, and he focused on trying to make the best speaker possible. He wanted to get rid, his goal was to get rid of the amplifier noise that plagued sound systems at that time. So here there was the connection of this wonderful story from his childhood linked 50 years later to what he was working on today, on a completely different field, gravitational waves, and yet there was that link. So I'm always trying to find that fun story, that how did a scientist come to this idea, to this field? And you'll usually find there's some great stories along the way.
Yeah, definitely. So that's something I was, when I started writing also, in the beginning, I felt like it's only going to be facts. I'm not going to have anything of these human stories. Why should we have that? The reader just wants the facts. But now it's completely opposite. Like I focus so much on the human element.
You want to blend it. You don't want to turn it into a People magazine article where it's just all personality and what they eat and what they look like. But along the way, to drop in those stories and those descriptions to give a sense of the humanity of the enterprise. Science is a human effort like anything else, like in the arts or in writing or in business or in sports. Everyone wants to know a little something about the person behind that endeavor. And science is the same way. It humanizes and shows that a scientist is not just this nerd with a white lab coat on them and divorced from the rest of society. They're part and parcel of civilization and engaged with the world. Ray Weiss is an accomplished pianist. That's wonderful to know that he isn't in this bubble just even though he's dedicated to his scientific work. He has all of these other cultural aspects that are part of him.
So talking about that, the human story, so one element of that, of portraying these scientists, is that physics and astronomy, it's a very male-dominated field historically. So thankfully that is changing a bit slowly, but too slowly, I think, everyone thinks. But so how, could you comment on that, how it has been to write about this male-dominated field? Because you have also spent a lot of time writing about, for example, women astronomers and their discoveries and highlighting them and their contributions.
It's interesting. It's a better situation in Europe than it is in the United States. I'm not quite sure why, but you're making more advances in Europe in bringing women into the physical sciences and engineering. Not so quickly here in the United States. But when I started out, my goal was to cover the frontiers of astrophysics. I didn't actually think in terms of gender. But what happened was the women came to me in the course of my seeking out the frontiers of astrophysics. There was Margaret Geller, Harvard Smithsonian astronomer, who in the 1980s was the first to see that galaxies were not just randomly distributed through the universe, but there was a large-scale structure. There's a foaminess. The galaxies actually array themselves as if they're on the surface of a bubble. It's a bubbly, foamy universe. She was the first to see that, along with her colleague John Huckra in the 1980s. There was Vera Rubin. I was looking through the literature. This is something I did a lot when I was covering the frontiers. I would spend time, this was before the internet, I would spend at least a day each week in the library reading the latest journals, and I kept seeing this reference to missing mass. And I started looking into it, and everyone told me, you got to talk to Vera Rubin. I was one of the first to do a story with Vera on her endeavors to prove that the dark matter truly exists through her measurements of the rotations of spiral galaxies. She discovered there had to be a lot more matter in the galaxy in order for it to not fall apart. There was Jane Liu at the time at Harvard, and she, along with a colleague, discovered the first Kuiper Belt object, the first object beyond Pluto, in a whole mass of material left over from the formation of the solar system. In fact, that's why Pluto was demoted to a dwarf planet, because they figured out that after discovering all these other Kuiper Belt objects after that, that Pluto was really the biggest of the Kuiper Belt objects. So
poor Pluto.
She was very important in that. So it's funny, the women were always there. It's just they weren't in the spotlight. And it took a woman reporter to find them, but I didn't seek them out. I mean, I didn't pitch stories just because they were women astronomers. I pitched a story because some new discovery or finding was coming, and lo and behold, the women were there.
So you said there's a difference between America and Europe in this term today, because now you have seen how things are changing over
I've
time.
seen some statistics, and there are more women physicists graduating with the degrees in physics and astronomy in Europe than in the United States. So we have to learn from some lessons from Europe, how you're doing it.
Yes. So talking about, I mean, you interviewed here, you one of the first interviews then with Vera Rubin, which is quite amazing. So I just have to ask, so she showed that by looking at the rotation curves of galaxies, how the stars are moving, that there has to be more mass there, that today we call it dark matter. But from what I read, she was a little bit skeptical in the end, because dark matter still hasn't been detected.
I think she was surprised along with me. I thought for sure, I wrote my first stories about her in the 1980s. I thought for sure we'd know it by now. And we don't. And that is one of the outstanding mysteries. But, you know, there were a lot of mysteries in science that took decades to figure out. Like the mysterious movement of Mercury's orbit. And they tried so many ways to try to explain it using what they knew at the time, which usually involved, there must be another planet between Mercury and the sun, and they called it Vulcan. And it took decades, and it took the discovery of Einstein's general theory of relativity to figure that out. Mercury's orbit was shifting because it was so close to the sun that its orbit was distorted by the bending of space-time, by the great mass of the sun. So it took a whole different idea, an idea completely foreign to all of the physicists and astronomers before that. Maybe the dark matter is a similar situation. Maybe we're not thinking it correctly. We're trying to find a solution based on known physics. Maybe we have to wait for something new to come along.
That's something I really look forward to. The day we will solve the dark matter mystery.
I would love it. I would love it.
Yeah. So one thing let's stick a bit on the topic of science stories. And one feeling I have is that there can be dangers trying to find like a perfect science story that you can present in documentaries or TV shows or small sound bites that is also dramaturgically enticing for the audience. And one example of this is, for example, when people say that Hubble discovered the expansion of the universe. Because you wrote an entire book about this, and when you actually deconstruct this statement that Hubble discovered the expansion of the universe, it's not that simple. So,
he did not.
Exactly.
Let me say that from the start, he did not discover. He confirmed it with his observational data. But there was a theoretical physicist, Georges Lemaitre, from Belgium, who had worked with Einstein's equations of general relativity and worked out theoretically and using crude data that he had at the time that indeed the universe was expanding. But he unfortunately published that article in an obscure Belgian journal that no one read. And he actually met up with Einstein at a conference to discuss this great excitement he had, to tell Einstein the universe is expanding. Einstein himself had a model that he presented where the universe was static, and he did not like the idea of space-time stretching and moving. So he just dismissed Lemaitre and said, your idea is absurd. So on top of publishing in an obscure journal, and Einstein, the most famous scientist of the day, telling you that your idea is absurd, you don't go talking about it on the lecture circuit. But it took then when Edwin Hubble did the famous Hubble diagram showing that indeed the galaxies were spreading apart in a uniform fashion, that 2 and 2 were put together. And Lemaitre really should get the credit for discovering the expanding universe, with Hubble given credit for providing good observational proof of that fact.
Right. So why do you think that it's often stated today that Hubble discovered the expansion of the universe?
It's an easy way. Lemaitre, through the history of astronomy, and I think a lot, because Hubble was based in the United States, a lot of the early histories, when you look back in the literature on the history of how the modern universe was discovered, there was a big focus on Hubble because he was the American, and they were American historians telling that story, that I think it was just an easy way to pump up the field of American astronomy. It was right at that moment, really, that with the new, bigger telescopes being built, first the 100-meter, later the 200-meter at Palomar Mountain, starting with Edwin Hubble, America was starting to be the premier place to carry out astronomical ventures. And so I think the whole story of the discovery was then cloaked around Hubble because of that momentum that was occurring with the bigger telescopes coming into play and the new discoveries. And Lemaitre's contribution got pushed to the side. But I think it is now getting recognized. In fact, just recently, within the last few years, the International Astronomical Union, they have renamed the Hubble constant, the Hubble-Lemaitre constant, because there is that contribution from Lemaitre. So they are trying to now bring that new history into play.
Right. So it's funny also that there's a Swedish astronomer called Knut Lundmark.
And Lundmark actually did some wonderful work on seeing that he was doing a lot of the work that Vesto Slipher was also doing at the Lowell Observatory. Vesto Slipher, a forgotten name, but in the 1910s, 1920s, he was measuring the velocities of the nearest spiral galaxies that surround the Milky Way. And he was the one who noticed that the galaxies were fleeing. Most of them were fleeing away. They had very high redshifts. And when Hubble presented his data for the famous Hubble diagram in 1929, the velocity information was coming from Slipher, not by Hubble. Hubble provided the distance information. He took Vesto Slipher's velocity information with no citation, no credit, and just used it for the diagram.
Right. So I think that's why Knut Lundmark, he complained about the Hubbleianism that was dominating.
Yes, and Lundmark himself had done some work on measuring the velocity of galaxies, though Slipher had the most. He had dedicated years and years finding that velocity information as far out as the Lowell Observatory telescope, which was far smaller than what was at Mount Wilson. He pushed it. He did just a yeoman's work doing that.
So a leading question then, in view of all of this, should science writers be careful to go for a simplified, individualized, easy dramaturgical story, like saying this individual astronomer did everything when he just looked up in the sky? Is it our job to kind of dig deeper and find
I think
the truth?
once we know the full story, it doesn't take that much to add and mention that Lemaitre first suggested the idea that the universe was expanding, working with general relativity, and that Hubble stepped in and provided the full observational proof. Easy. You don't have to, you don't have to say Hubble discovered the expanding universe. You can go 2 sentences rather than one. Right. And then slowly, as that story is reformed, then it gets set into stone. A similar thing is happening now with Watson and Crick with DNA, and the role of Rosalind Franklin in providing the crucial image that allowed them to develop the structure of DNA and how the DNA molecule worked. So I think once that information gets a little more distributed out there, I think each science writer, they should make sure that they include a few nuances along the way. I learned with my work at Discover magazine, where sometimes we would have to edit, and depending on the number of advertisements, I had one story where I was told I had a 3-page feature, and I was told that an advertisement had come in and I had to cut a full page of my story. And I said, impossible. But I sat down with a wonderful man who was a longtime senior editor in the Discover, then was part of the Time Inc. Media empire. And he had a long hand at editing. And he worked with me sentence by sentence, paragraph by paragraph. I was able, in my mind, to retain the story and have a full page taken away. And that's where I learned the lesson. You can always edit. You can always find a way to tell something shorter. And I think we can learn to not be lazy in hand-waving a fact that is in itself inaccurate. I cringe every time I hear the word Hubble discovered the expanding universe. I cringe because I know it didn't happen that way, and it would take just another sentence to change it. Right. And make the people aware. Right.
It's a very good statement, and I think that's another advice then to to take away from this episode, this talk, is to, be historically accurate. And
you can. Yeah. It doesn't take much to check the facts and write just a little more nuanced sentence to make it just a little more accurate.
Perfect. So we're going to slowly start to wrap up, but I have some questions I still want to ask. And before we are going to wrap up, first of all, I want to just like to know, what science result and story have you been the most excited to write about?
Well, the one of the current era is definitely gravitational waves, because I had that opportunity, the way I saw Walter Sullivan, the New York Times reporter, write on the origin of radio and X-ray astronomy. I had the opportunity to be on the ground floor and see a whole new field of astronomy from the start, when it was just an idea and a picture on a bulletin board. And then I saw how the field grew, how they carried out tests, how they went through Congress to get the money, and there are plenty of stories about that. And then finally getting the money, starting the construction and then being there as they were constructing the observatories. I had the wonderful moment when I was in the clean room, when they have, because these mirrors are, I think I once used the metaphor that about how smooth these mirrors are. You cannot have any dust or dirt on them at all, or it would ruin the experiment. So they have to be in a very, very clean room. So I was dressed up in those bunny suits, they call them, where you're all wrapped up to make sure that you're not inserting any dirt into the room. And I went into the tube where the mirrors were, where they were starting to hang them within the long tubes. And I was able to see the equipment that is now totally out of sight until they take it apart. But this is not something you can see. You actually have to wait until they actually take it apart to see the mirrors and all the equipment. To be like that and to see it, I felt as if I was right by the side of Galileo when he had his little telescope looking at Jupiter and the moon. It was that exciting to me.
So that's really the holy grail of gravitational wave research, is to see the mirrors.
Yes! To say, I saw them as they were putting them in. Yes. Right. Such fun. And then to see the actual detection, though I was getting a little impatient there. It took 15 years. I was a little surprised when they finally called me to say, we found something. They did, because I did the book. I was very fortunate to get some advance notice. So I was brought in on the secret while they were checking all of the details, which enabled me to arrange for a second edition. And I flew down to the Louisiana LIGO and interviewed everybody about what happened when they first saw the chirp, they call it, because it does sound like a little chirp when you play that frequency recording in sound. It goes whoop. And so my chapter was called The Chirp. And
that was a really good imitation of the chirp, by the way.
Yeah, that's two black holes colliding. Yep. Whoop. And so while it was still fresh in everyone's mind, I interviewed everyone, and I got such great stories, the behind-the-scenes stories of what it was like to be part of that detection. And for many weeks, they were so worried that it was just a false signal. So they really went to the rails to prove that that was truly a gravitational wave signal. And now they're seeing stuff every day. I mean, beeps all over the place. And they have two other observatories now, one in Japan, one in Italy, and one starting construction in India. So it's becoming a global enterprise.
Yeah. So it sounds super exciting. You were there and you got to see this new field of astronomy developing as it happened. So let's wrap up and talk about advice for new young science writers who want to get started. Because I guess everyone, this is exactly what you want, right? You want to follow a new field developing and the new signal as it emerges.
Yes.
So what advice would you give to someone starting out?
Sometimes it helps to have a niche, which is what helped me, is I found my niche in astronomy and astrophysics. There are some science writers who are more broad-based and will cover a variety of different topics, from biology to geology to physics and astronomy. But it can be helpful to get your name out there, the editors started knowing me as the go-to person during the 1980s for when some new finding, discovery happened in the area of physics or astronomy. My name would be at the top of their list because they knew I had the background. They knew. So I often, towards the end of my career, never had to write queries because they would be calling me to cover some new story. So, that's maybe not everyone's cup of tea, but I loved it. You know, a lot of people have said, "Oh, Marcia, how could you stand just covering one topic over and over and over?" And I said, how can a scientist work in one field over and over? There's always something new. There's always something past the horizon that is going to surprise you, and the curiosity never ends. So that's helpful. Now, I grew up in an era of science writing that was primarily print. And even though I had a broadcast background, I completely switched to print and really stuck with that. Nowadays, and I went on to become a professor in the MIT graduate program in science writing. And we did start out at first focusing on print, but we realized with the changing in media environment and with the introduction of the internet and all that comes with that, you really do have to be a jack of all trades and learn a little about, as you are doing, podcasting, video production. And so we started introducing that into the program. Our students not only get really good background in writing news stories, features, profiles, even the history of science, but also they carry out assignments in podcasting and video production. And that has, looking now at our graduates, been an immense help because a lot of times if they work for a website, even though they're primarily doing stories for the website in print, their skills in video and audio production have enabled them to also do those aspects to add to the story. And their editors have appreciated that. So I think that's another thing that newcomers coming to the field should think about expanding their skill set and trying it on, seeing how it works. Because they are different skill sets. It's different when you're doing an audio story than a print story. But you can switch. You can change hats back and forth.
Yeah, and luckily the technology has evolved tremendously. So it's not like before where you had to carry around a super expensive video recording device that's very hard to operate. So.
Exactly. I had gotten an offer from National Public Radio to maybe be a science correspondent on a freelance basis. And I had to buy my own equipment. And back then, one, I didn't have the money. And two, it just seemed so awkward. And so I sort of put that aside. But now, much easier.
Yeah. So one final question is, do you have anything else you would like to add to this talk that I didn't ask about, or anything that popped up in your head that...
Suddenly my mind goes blank.
Okay.
But no, I can't think of. I feel like I've been rambling, and hopefully all of this is not going to be used. Uh-oh, there's a look in your face. It is. Oh dear.
Well, yes. No, but Marcia, it's been great to have you on this episode and talking about the craft of science writing, and also hearing about your enthusiasm about science writing. I think that comes across quite clearly. I would actually like to ask one final question, which I've been thinking about as my own career as a science writing is progressing, and that's, how do you reach out and maintain a relationship with the scientists that you're interviewing? Because that's something I noticed that, I mean, it's an integral part of being a science writer is to expand your network, but that can also be challenging to get access to different scientists.
Sometimes you have to understand upon meeting them whether they are media friendly. Some scientists, they just want to do the interview and you're out. Others seem to be engaged in the process. And then you realize this would be a good source to keep in touch with because they're eager to get the word out and to communicate. So I always, I still have it. I still have a Rolodex.
What did you call it? A Rolodex?
Rolodex is, this rotating address book where you have a set of cards on a wheel. And starting in the 1980s, I started every time I interviewed a scientist, I would have their phone number, their name, their contact information, and I would put it in the Rolodex. And if I came upon a story that happened to touch upon their field, then I knew I could call them up and keep in touch. And also attending conferences and keeping in the loop. That was always very important too, is attending the big national conferences like the American Astronomical Society conferences. I did that a lot in the 1980s and 90s, and that kept me in touch with a lot of scientists because you meet them in a more informal manner, in a more informal way, and able to go out to lunch with them, have informal chats. And they're more relaxed and prone to tell you that there's something coming down the line that I should be on watch for. So,
that's something I noticed.
Keep in contact with your sources, definitely. Even though you think you're never going to see them again, you'd be surprised how sometimes you rely on them. Not because they're a part of the new finding or discovery that you're working on, but they're tied into the grapevine and they can give you some background information that will lead you to the right people to contact. Oh, you must talk to this person or you must talk to that person. So that's very important to network is definitely part of any journalist's game.
Right.
It's not any different in science writing than it is in regular journalism, is you keep in contact with your sources.
I definitely agree with this experience that it's when you eat lunch or you have after conference dinners or a few glasses of beer or wine.
Yes.
That's when you hear the really important stuff that
Yes.
can change your entire direction of what you're writing about. So.
And something else is be ready to tell them you don't understand what they're saying. And this is
Right.
another thing I said, when you sit down with a scientist, you often feel like you must sort of be this person that shows that you know what you're talking about. Sometimes it helps to just look and say, I don't understand that. Is there another way to put that? I'm not getting it. How can I understand this a little better? And they'll change their level. Sometimes it helps, sometimes it hurt. If they knew I had a background in physics, sometimes, especially when I was first starting out, there were those senior scientists, the senior males, who didn't trust that this young woman, would understand what they were talking about. So I would sort of throw out the graduate degree to give them a sense of comfort. And then through my questions, sometimes I'd be even a little more technical to let them know I understood. I understood what a Fourier transform was. So you can be confident that I understand what you're talking about. But other times it can be to my detriment, because then they're talking up here and I really want the quotable quotes where they're talking to a general audience. So sometimes you have to really let them know, let's find a way to describe that so that my mother can understand it. And,
Right.
And be ready to be not putting on a show that you're the all-knowing reporter. But you want to also let them know that you've done your homework. They appreciated that I read the literature before I came to interview them. They like that.
Have you noticed this thing when you do an interview with a scientist and say it's a long interview, 1 hour maybe, and then you go through all of this stuff, and then it's during the last 10 minutes when they know it's about to end and they have built a confidence, or you have built a confidence with them, that's when they really tell, you get the really good quotes,
yes,
and really the inside story and everything. Have you noticed this?
I have seen that at play, yes. And sometimes I try to keep them engaged enough that they go past the what they had on the schedule and that I get to talk to them a little longer.
Right, yeah. Okay, I think it's time to wrap up. Thank you so much for this talk, and that's it.
Jonas, it was a delight. I often talk about the science, but not the art of science writing, so this was fun.
Great. Thank you, and bye.